Okay, let's continue talking about how we graph linear equations and functions as we begin to talk about what is known as direct variation. Direct variation is a specific type of linear equation that we'll talk about as we go on. It deals with ratios and proportions. Um, so remember when we talked about input and output, defining that this was a function because for each input we had an output. And there was a rule for that. You go to the gas station, you pump in gas, and you pay a certain amount. That amount gets multiplied by the price per gallon. So we'd say this is a direct variation function because you're multiplying by a constant of variation. And so that constant of variation is known as the amount that you pay per gallon, whether it's 265 in this case. And that's all we're doing. You don't pay any extra added on fees. So two variables, x and y, have direct variation. And we use this equation to show that y equals a times x, as we're multiplying whatever the x value is times a. So in this case, multiplying the number of gallons times the price per gallon to get our total cost. A is known as the constant of variation. And that constant of variation is just the value that we multiply by to get our y value. And in that case, we say y varies directly with x. It's directly proportional to x. So one way to think about it is there's only one step in the function machine. We're only multiplying. Another way to think about it is it's proportional, or that the y-intercept is always 0. Our graph is always going to cut through the origin because we're multiplying by a certain amount, and multiplying anything times 0 is 0, so we'll always have 0, 0 as one of those points. So let's take a look at these equations and determine, first of all, if they are direct variation equations. So we need to get them to y equals. So subtract 4x in the first example. And we get 2y equals 0 minus 4x is negative 4x. And then we divide by 2. So y would equal negative 2x. And so our constant of variation, we would say, yes, this is direct variation. I'll just abbreviate it, dv, direct variation. And the constant of variation would be negative 2 because we're multiplying x by negative 2 only. Next example, we add 2x to both sides to get y by itself. And we end up with y equals 2x plus 3. And you notice x is multiplied by 2, but then we add 3. This one would not be direct variation because it doesn't vary directly. We also add in a value. Okay, so that's how we can tell by looking at the equation. Let's look at the table. Okay, if we have a table of values, well, can we tell if it's direct variation? Does each x vary directly with y? 1 to 5, 2 to 10, 3 to 15, 4 to 20, 6 to 30. Well, it appears to me that it's multiplying by 5 each time. And that's all there is. So we would say that y equals x times 5, or 5x. And we'd say, yes, that is direct variation because all we're doing is multiplying each time. Look at the example on the right, negative 3 to negative 2. Could be multiplying by negative 1.5. But then this one doesn't work, so it's plus 1, plus 1, plus 1, plus 1, plus 1. So the rule would be y equals x plus 1. And we would say that that's not direct variation because we are not just multiplying by a value, we're adding something else in. Okay, so let's graph these direct variation equations. Keep in mind that these need to be equal or have a x or y intercept of 0. Sorry, I can't talk right now. So we could choose some points and evaluate those points. Let's choose 3 points. 0 times 2/5 is 0. 0, 0. 2/5 times 1 is 2/5. 2/5 times 2 is 4/5. this is this equation, 1 2/5 to 4/5. And I could draw my line through there, through those points. And then let's try another example. Y equals -half x. And we could do the same thing, put in some values for our domain. -half times 0 is 0. -half times 1 is -half. -half times 2 is -1. Plot those, 0, 0. 1 -half, and 2 -1. Connect the dots. And there we go. We've got two direct variation equations that we've seen we know how to graph. It goes through the y axis and gives us a y-intercept of 0. So those should always have 0, 0 as one of the coordinates. Now let's say we want to write a direct variation equation where we're only given that the graph passes through the point 4, 6. And we want to find the value of y when x is 24. So we know one of the points is 4, 6. And we want to know when x is 24, what's y? Well, if we're told it's direct variation, so we know it varies directly, we're multiplying by something. Well, how do I figure out what I multiply by? 4 times what number equals 6? Well, it's not a whole number. So if I divide 6 by 4, kind of reverse the order, work our way backwards, do the inverse. 6 divided by 4 is 3/2, or 1 1/2, 1.5. So I know I'm multiplying by 1.5 to get to 6. So if it varies the same way, I'll multiply 24 times 1 1/2. And that would give me 36. So y is 36 in this direct variation equation. Another way that I could do that, well, I know that 4 is to x 6 the same way that 24 is to, we got ourselves notice a proportion. Direct variation equations are proportional. So in the same way we could do the next example. But before we do that, we want to write the direct variation equation. So y equals, well, what constant of variation are we multiplying by? 1.5 times our x values to get y. Okay, why don't you try this bottom example? Start the video when you're ready. Okay, so I can compare the x and the y. So if I divide my y by x, I get 2/9, which would be my constant of variation. So my equation would be y equals 2/9 times x. Multiply my x by 2/9, and I get 6. Okay? So that's what's explained here with those, how to find the ratio. We just take our y divided by x to find our constant of variation, or a value, then plug that into our equation. So the ratio of y to x is constant for all those ordered pairs. So that's why we can apply that to any ordered pair. Take a look at this example with online music. It says the table shows cost C of downloading S songs at an internet music site. So this is our input and our output. So why does C vary directly with S? Well, can I figure out what I multiply by to get my cost? Is it a constant variation? Well, I could check. What's 297 divided by 3? Is it the same thing as 495 divided by 5? Is it the same thing as 693 divided by 7? And as we divide all those, we see that it's always 0.99. So if I multiply by 99 hundredths, or 99 cents per song. So the equation's cost equals 99 cents per song, so 99.99 S. All right, so that is direct variation. It relates directly to proportions that we've learned already, and it connects with graphing linear equations that we talked about last time. All right, have a good day, evening, morning, whenever you're watching this. See ya.